Today we're going to start explaining the atomic structure. And that's the first step in order to explain the different properties that we encounter in nature. As we previously said, the nature of different substances and their properties are actually dependent on the matter-energy interaction. And it's actually a really essential part that enabled us to understand the atomic structure early on. And we specifically built our understanding for the atomic structure on the interaction between substances and light. Basically, how different substances absorb or emit light when they interact. What was observed later on is that some substances actually absorb and emit all frequencies of light or colors of light in what is called a continuous spectrum, as you can see right here, while other substances, when it interacts with light, it emits or absorbs specific colors or specific frequencies in what is called line spectrum. Enabled us to start building different models to explain the nature of the atom. And in order to do that, we need to understand the nature of light. So early on in physics, light was known to be a wave. And any wave is a periodical motion, like the motion of this red point right here. So that's a periodical motion that can be described mathematically with what we call a wave function, as described by this equation right here, while the displacement of that red point on the y-axis is defined according to this equation to equal a, which is the amplitude, the maximum displacement possible, times sine 2 pi nu t. And u here is the most important parameter that characterizes the wave, is the frequency. It's the number of waves that takes place per second. That's why it has the unit of second minus 1, or sometimes it's called hertz. So in order to define any wave, you only need to define one parameter, which is the frequency, nu. Alternatively, you can define the wave based on its wavelengths, because wavelengths and frequency are inversely proportional. And the wavelengths here, it's the length of a complete wave, the distance between one point and a second identical point. Third alternative way to define the wave is called the wave number. And wave number is basically the inverse of wavelengths. So being the inverse of wavelengths means that it equals the speed of light times the frequency nu. So again, you can define the wave based on wave number, as we were previously able to define it based on wavelengths or frequency. So we have three alternative parameters that define the wave. So based on this, the first skill that we need to learn is how to interconvert between these three parameters. So if you know the wavelengths of a given light, you can easily calculate the frequency based on the relationship between wavelengths and frequency, because wavelengths equals speed of light, or wave speed, divided by frequency. So if you want to calculate the frequency, nu is gonna equal the speed of light c divided by wavelengths. So it's gonna equal 3 times 10 to the power 8 meter per second, divided by wavelengths, but you have to express wavelengths in the same unit as the speed of light. Speed of light is defined as meters per second. So you have to convert wavelengths from nanometer to meter, which is going to be taking the value in nanometer and then multiplying this times the conversion factor between 1 nanometer and meter, which is 10 to the negative 9. So you carry out the math that is going to give you the frequency as 9.23 times 10 to the power 14, which is going to be second minus 1, because meter is going to cancel with meter and nanometer is going to cancel with nanometer, and you'll be left only with second minus 1.